Is this mastering compressor with over 30 parameters one of the hardest to learn. It offers the ability to manipulate the transfer curve, sidechain signal, and envelope in a way that just you cannot compare to other compressors. So don't forget to smash the like button, subscribe, and let's dig in. We have our ratio, which goes from 1:1 to 20:1, and that goes in 100th step increments. That is the resolution of how far you can tweak this ratio. So 1.65, 0.7, 0.71, high resolution. Also, you need to take note, I'm going to put this back to 4:1, but take note of this glowing little light near where the indicator is. It indicates how the ratio will be modulated or is being modulated when we explore parameters like the X ratio in the sidechain module later on. So you can actually manipulate the ratio dependent on the signal, and we're going to explore that in the next module later in this video. The next thing is your knee, and that introduces a transfer curve centered at the threshold between the lineal state of the signal and the full amount gain reduction. So if we see here, and we go 13.5, we'll see that 6.25 decibels below, it starts to transfer from its lineal state to its full amount of gain reduction. Next is relax. Now, this sets an inverse or logarithmic outcurve. So when the compressor reaches full gain reduction, it actually starts going back to unity or linear response. Now, that might be confusing the way I've worded it there, and Rune told me it's probably going to be easy to explain it like this. It softly reduces the maximum amount of gain reduction. However, for me, inverse logarithmic outcurve or exponential function just sounds pretty damn cool. Now, back to the audio side. This is a pretty typical interaction between a light source and a light-dependent resistor you'd find in an optical compressor. It backs out after reaching max gain reduction, and this is really good when you want to control peaks inverses but not absolutely crush the life out of the overall signal when a big chorus hits, because you can allow it to ease off.
Take the top down in my brand new spaceship, lost and then found you so far away, and doing just fine, don't need your compensation, can't waste my time, so it's back to the basics.
Gain reduction limit sets the maximum amount of gain reduction to a specified value. It's linear in its onset, unlike the relax mode, but very practical if, let's say, you only want to apply a maximum of, let's say, 2 decibels of gain reduction. It will not allow the compressor to do more than just that. The attack and release at face value operate like you'd expect on any compressor, setting the time constant for gain reduction above the threshold and how it returns back to unity when it goes back below the threshold. And while we discuss the envelope, we're going to have this tone burst chart, attack and release chart, so we can plot and monitor how when we move the attack and when we move its modifiers, because there's more than meets the eye here with the envelope module, we can see how it affects a signal and we can manipulate and change and shape the tone of our transients. Now, the RMS speed and peak sensitivity of the detection circuit, which we're going to look at in the sidechain module, is going to affect how the attack and release stages react to signal changes. So for demonstrative purposes, I'm going to link the RMS speed and the peak gain detectors on the multiband detector, which we're going to look at later in the sidechain module, only to show you how this impacts and modulates the envelope. So first I'm going to bring peak gain all the way down because we don't want to concern ourselves with the peak gain. I want to show you RMS speed first. So RMS speed is an RMS modulated window where either it has a slower window or a more open time window or a quicker window. And that's really important to understand, because RMS doesn't mean that it's detecting more RMS or less RMS or more peak gain or less peak gain. It's actually the speed of the window. So there's no real way to equate that to milliseconds other than it's a hertz. So lower means larger window, faster or higher frequency means it's a shorter window, and it modulates the envelope in that sense. The next thing is to look at how much of this envelope do you want the peak to be detecting. So whilst we can modulate the RMS here, the peak is really important, because it's like, well, how much of the peak is going to trigger? Is it going to be more peak triggering or less peak triggering? And you'll make that decision based on the nature of the material. Now, in terms of the direct attack and release modifiers, the loud X and quiet X time. Now, the loud X, quiet X parameters modify the attack and release relative to the current state of game reduction. So whatever game reduction is happening at that instantaneous moment in time. So a steady signal causing a lot of game reduction is considered loud at its onset, but once the game reduction reaches its target range, it's considered quiet. So it starts modulating to the quiet modulate. And these modulate the attack and release times by multiples. So if you want to multiply your attack time from 100 to 200 milliseconds when it's allowed, a 2x multiple is what you'd use, and then vice versa. You can actually make it quicker. So these x values for both the loud period of when it's compressing fast and the quiet time when it's reached its target can either be modulated at greater values than 1 or lower values than 1, either speeding or slowing down the time constants, as this is indicated by the light next to the parameter, which one is currently engaged. Then you have the crossover between loud and quiet time, and this controls the crossover point between what the compressor considers as the loud stage and the quiet stage. Here's an example. If I really want to beef up the weight of drum hits, I'll use a long multiplier for the X loud time, a really short multiplier for the X quiet time, and I'll A/B this for you on the drum so you can, number one, see the different envelope and also hear the audible change. The next modifier for the release curve allows you to blend the shape from logarithms to linear return to unity. I found this especially useful in both heavy dance music, where the release curve greatly affects the feel of the sub bass, and in cinematic or orchestral music, where elements, the envelope is really important because you can hear any release on a game reduction circuit, especially in strings or the way the shrill or reverb and tails of things are. So what we can see here is a logarithm, okay? But then if we change it to linear, we'll get a straight line back to unity. So you can actually change the shape. So a logarithm is a little bit more smoother. You don't feel it hit back into unity as much, and linear is just a straight line up. Where X loud and X quiet are considered micro modifiers affecting the attack and release curve relative to the current state of game reduction, memory effect is modulating timing on a macro level. And this modulation's effect can actually be monitored in the sliding light scale around the attack and around the release parameter knobs. And the way these memory modifiers works is basically if there's more game reduction, so if there's more going over the threshold, more modulation, and intensity can be defined by how far that threshold has been exceeded. So what we can do here is we can actually see if we add this modulation, you can see the attack time slowing down. Okay, see that light marker there going round and this envelope opening up? You can actually change that. So the more game reduction, the slower the attack. What you can also say is the more game reduction, the faster the attack, and you can speed it up or slow it down based on the amount of game reduction period. And then you can do the same with the release. The more game reduction, the slower the release. And you can see that light modulating there. Or the more game reduction, the faster the release. So you want it to be more aggressive. So you can change the tone of the compressor using those envelopes. You've also got a transient override, and that allows the transients to be compressed with a different timing to the main envelope. So what you can say is, well, we've got the attack set for 45 milliseconds or 46 milliseconds for everything, but I want my transients to be much slower than that. Or I want my transients to be compressed much faster than that. And that's really important when you want to retain some of the snap in a song, or you want to control some of the transients in a song different to the overall body of it. The next modulation option here, and again, it's just modulation on top of modulation using this compressor where you can just the possibilities are endless, is the second envelope. And this second envelope is additive in nature. At 0, so if we have this second envelope at 0 milliseconds, it's a direct replica of the attack and release times you set at the start of the envelope here. However, as you turn the dial, so 100 milliseconds, you create a second envelope that is additive of the original attack and release times, which you can use to blend in. So you can blend in how much of that envelope is actually affecting it. So if I make these envelopes really big, I can blend in this second envelope to the original one. You can see that happening there on the envelope graph. This, in my opinion, is an alternative to transient override, whereby instead of simply allowing the primary envelope to override and manipulate compression, based on transient information, you can instead set up a secondary envelope that is slower and responsive to the entire signal to blend back in rather than just observing transients only. Next, we're going to be talking about the sidechain filters, namely the multiband detector. Now, the multiband detector is at the heart of why so many pro mastering engineers and producers gravitate towards the Unisum compressor. It allows independent RMS and peak detection control for each of the 3 bands, which you can set the crossover points to, allowing you to modulate how both the envelope and the transfer curve interacts with different frequencies. So everything we've done up to now, the transfer curve and the envelope, we can further modulate or change its interaction using the multiband detector. First, you set up your crossover points over here. Now, these are 12 decibel per octave crossovers, and I tend to set the crossovers 1 octave away from the fundamental. So let's say the kick and bass energy is from 200 hertz down. I'll set the crossover here to 400 hertz. So that way I've got that 12 decibel per octave crossover slowly filtering in, and by the time you're at 200 hertz, you've got most of the signal triggering. Now, the frequency values of the RMS speed control an average filter window. More or less RMS detection or more or less peak detection will dictate on the speed of the RMS you choose and how much of the peak you're allowing into that signal. Weight controls how much of each frequency band controls the amount of compression, and this modifies plus or minus is directly relative to the threshold. And we can see this directly here. I've got a 200 hertz wave coming through, and I've got this lower band here. So if I wanted to start compressing sooner, I can add the weight 5 dB, and it's going to actually start compressing at a lower threshold for those lower frequencies, or it's going to be triggering at a lower threshold. The next thing is the X ratio, and it modulates the ratio parameter of the transfer function on the basis of each frequency band's level. So at the moment, we're at a 4:1 ratio, and if I want to be at an 8:1 ratio, and I go 2x for all my low frequencies, look how that transfer curve changes. So basically, my low frequencies are going to trigger a higher ratio of gain reduction, or I can say I want the low frequencies to actually trigger less gain reduction. Let's make it 0.5, and what we can see here around the ratio is that little light modulating it down to 2:1 from its 4:1 originally. Next is HYGGE, or Hygge. It's pronounced Hygge, coming from the Danish word to give courage, comfort, joy. So here is with it out, no harmonics being introduced. Obviously, I'm not doing much compression, period, so that's not going to happen either. But as soon as we introduce Hygge, we get some harmonics, and then we start to introduce some 3rd order harmonics, some 2nd order harmonics that are slightly softer than those 3rd ones. A lot of those harmonics are geared below 500 hertz, so it's a much warmer tone overall. The next thing to look at is channel linking, which is this knob here. Now, turned fully left, 100%, the compressor is going to provide the same amount of gain reduction to both the left and the right channels. Then if we turn it fully right, it's going to be 2 mono compressors, one for the left, one for the right. But then what we can do is we can create an RMS peak bias on the channel linking, which is really important because what we can do here is we can allow separate control over the linking of the RMS and peak detection circuits. So if we turn this to bias fully left, 100% RMS, that means that the average RMS detectors are going to run in sync as stereo linked, and the peak is going to remain independent. And then if we go the other way, 100% peak, the peak values are going to compress together, completely linked, and the RMS is going to follow whatever we've got here in the channel link. And then finally what we can do is we can say, yes, we're going to have them completely unlinked, but we're not going to allow the two sides of the compression to compress any more different than 2 decibels between the left and the right channel, or 5 decibels between the left and the right channel, depending how much difference there is or how much difference we want there to allowed to be had. So all in all, how hard is this compressor to learn? It is very difficult to learn. It's been out for 2-3 years now, and I didn't get it at the start because it was such a hard learning curve. However, the last 2 to 3 months, I've knuckled down. This video is a testament to me learning the plugin and understanding all the parameters and how they interact. And I can say after putting that time and effort in, it is worth knowing. It is a worthwhile tool to have in my toolkit because I'm actually in sessions using it, troubleshooting tricky mixes with lots of bass or really interesting dynamics. And this is knowing how to use this plugin has allowed me to do things I otherwise couldn't do with other compressors. So there you have it. Make sure to like and subscribe. And until next time, take care.